Hi, good evening, everyone. Good evening. So we are starting papers today. Yes, I have sent you two papers. Shall we start with May, June 2021, paper 22. May, June 2021, paper 22. Hello, people online, can you hear me? Hi. Guys online, can you hear me? Yes. May, June 2021, paper 22. Question number 1. Complete the table by stating whether each of the quantities is a vector or a scalar. So guys, acceleration is a vector. Electrical resistance is a scalar. Momentum is a vector. Correct? Should I remind you what is a vector and what is a scalar? I don't have to go that low, right? Very good. State the conditions for an object to be in equilibrium. There are two conditions should be satisfied for an object to be in equilibrium. One is the resultant force in any direction should be zero. Okay. Condition number 2 is the resultant moment above any point should be zero. Which means if you take the moments above any point, the total clockwise moment should be equal to total anti-clockwise moment. So you can say resultant force in any direction should be zero. And resultant moment about any point should be zero. Those are the two conditions required for an object to be in equilibrium. Okay. Right. Part C. A floating solid cylinder is attached by a wire to the seabed. As shown in the figure 1.1, the density of the water is given 1000, 1 into power 3, which is 1000 kilograms per cubic meter. The base of the cylinder is at a depth of 0.190 meters below the surface of the water. The cylinder has a weight of 28 newtons and a cross-sectional area of 0.023 square meters. Right? The wire and the central axis of the cylinder are both vertical. The cylinder is in equilibrium. Calculate the three significant figures, the upthrust acting on the cylinder due to water. So when the upthrust is given by what? Upthrust is equal to what? Okay. Guys, the upthrust is equal to what? Upthrust is equal to what? How do you find the upthrust? It is one way that you can consider is the difference in pressure multiplied by the cross-sectional area. Or else the easiest way is V rho G. That is the equation we use for upthrust. If there is anyone here who did know this equation, who was not here during we did the theory for some reason, you can take down this equation. The upthrust acting on an object which is in a liquid is given V rho G. That is the formula to find the upthrust. where V is the volume of the displaced liquid, rho is the density of the liquid, G is the gravitational field strength, the regular 9.8. Okay. So guys, V is the volume of the water which is being displaced. The volume of the water which is being displaced is the volume of the cylinder which is within the liquid. That means this volume is the volume of the cylinder which is within the liquid. That is the volume of the water which has been displaced. So that is the V we are going to take. So how do we get the V? The cross-sectional area multiplied by this height. So the cross-sectional, the volume of the cylinder is given by cross-sectional area into height. So what cross-sectional area is given? 0.023. 0.023 cross-sectional area into that height or the depth of the cylinder which is within the liquid is 0.19. This will give you the V into rho, that's 1000. G is 9.81. G is taken 9.81. This is the G, not 10. It's 9.81. So that will give you the thrust. .87 or 42.9 newtons. We give the answer to two significant figures in the answer space, which will be 43 newtons. Okay. Show that the tension T in the Y is 15 newtons. So guys, if you look at the cylinder, what are the forces acting on it? Can you tell me what are the forces acting on the cylinder? Definitely the weight is acting down. What else? Up thrust is acting up. What else? Tension is acting which way? Down. So that is when you mark the tension, it is always two inverted arrows, right? That's how always we mark the tension. So this arrow says, this arrow, the one on the top, that arrow says the weight of the cylinder is downwards. Sorry. The force on the cylinder is downwards. The tension on the cylinder is downwards. This arrow says 1. The force on the seabed is upward. This mark shows this is a seabed. Okay. This cable or string or whatever they have given is attached to the seabed, right? So an upward force is acting on the seabed. So basically, this arrow says the force acting on the cylinder, and this arrow says the force acting on the seabed. Okay. So we don't need details about the seabed for now. We are concerned about the forces acting on the cylinder. So the W and the tension are acting down. Up thrust is acting up. So now since the cylinder is under equilibrium, the addition of W and T should be equal to U. Right? U equals W plus T. U equals W plus T. So the U is 43. And the W is, what is the W? 28 plus T. So the T equals 43 minus 28. That's 15 newtons. Okay. Any questions, anyone? The next one. The wire has a cross-sectional area of 3.2 square millimeters. Calculate the stress in the wire. So again, the stress is given by force over area. So force in the Y is 15 newtons. Over the area is 3.2 square millimeters. How do we convert square millimeters into square meters? Square millimeters into square meters. Multiply by 10 to the power minus 6. Which way will be? .7 into 10 to the power 6 pascals. Am I right? Square millimeters into square meters is 10 to the power minus 6. If you just want to convert millimeters into meters, you multiply by 10 to the power minus 3. It is square millimeters into square meters, it is 10 to the power minus 6. If you want cubic millimeters into cubic meters, it is 10 to the power minus cubic millimeters into cubic meters. To convert, you need to multiply by 10 to the power minus 9. Okay? Agreed? Yes. Any questions, anyone? Right. The surface of the water gradually rises until it is level with the top face of the ceiling. Okay. The surface of the water gradually rises until it is level with the top face of the ceiling. State and express qualitatively the variation of the strain energy stored in the wire as the water surface rises. Do you understand the question? Now this water level is rising. Okay. So guys, tell me, if the water level rises, what will happen to the upthrust? Will increase. Correct? Upthrust will increase. So if the upthrust increases, what will happen to the tension? Will increase, because upthrust is equal to W plus T. W is not going to change. So if the upthrust is going to increase, the tension will also increase. So that means tension is the force in the string. No? So if the tension increases, what will happen to the energy stored in the string? Will increase, because the energy stored is given by the strain energy stored in the Y is given by half into F into X. Correct? So if the force developed in the string is increasing, the force in the Y is increasing, the strain energy will also increase. So state and explain qualitatively. It will increase. So guys, now look at this, the way the mark is allocated. It's a 2-mark mark. So definitely 1 mark is given for stating whether increasing or decreasing the conclusion. So the other 1 mark is what given for the explanation. So the explanation has to be proportional to 1 mark. You can't write a story here. Don't waste your time. Okay. So simply we can take the explanation. Upthrust will increase. So the tension will increase. That's it. Tension is increasing, so the strain will increase. That's it. Right. Question 2. I'll give you a minute. Read the question, everyone. Right. Question 2. A ball is thrown vertically downwards to the ground as illustrated in the figure 2.1. The ball is thrown with speed u from a height of 1.5 meters from the ball, then hits the ground with speed 8.7 meters per second. Assume that air resistance is negligible. Calculate the speed u. So guys, u is the initial speed, v is the final speed, and the height is 1.5 meters. And we know the acceleration while it is falling, it will be the gravitational acceleration. So the equation which connects this v, u, a, and s is am I right? V square equal u square plus 2a. So the final speed v is 8.7. So that square is equal to u is what I want, u square plus 2 into a is 9.81. S is 1.5. From here we can get the u square subjected at the u. That will be 6.8. Yes. The next one. State how Newton's third law applies to the collision between the ball and the ground. So guys, when the ball hits the ground, there will be a force exerted on the ball on the ground. There will be a force exerted by the ball on the ground in the downward direction. So there will be a force exerted on the ball by the ground in the upward direction. These two forces will be equal in magnitude and opposite in direction. Okay. So how can we state how Newton's third law applies to the collision between the ball and the ground? So you can tell ball exerts a force on the ground in the downward direction. Ball exerts a force on the ground in the downward direction. Kabam. The ground exerts an equal force on the ball in the upward direction. Okay. The ball is in contact with the ground for a time of 0.091 seconds. The ball rebounds vertically and leaves the ground with a speed of 5.4 meters per second. The mass of the ball is given. Calculate the magnitude of the change in momentum of the ball during the collision. So guys, the ball hits the ground with a certain momentum and rebounds with a certain momentum. The momentum with which it hits the ground is, I can find it, mass into velocity. Mass is 0.059. 0.059 is the mass. Into the velocity is 8.7. 0.059 into 8.7. 0.5133. Newton seconds or kilogram meters per second. That is the momentum at which the ball will be hitting the ground. Then the ball will be rebouncing the ground with a velocity of 6.8, which means mass into velocity will be 0.059. 0.059 into 6.8. So the rebouncing momentum is 0.4012. Newton seconds or kilogram meters per second. So now 0.4013 is the rebouncing momentum. 0.5133 is the hitting momentum. What will be the change in momentum? How do we get the change in momentum? You have to add them together. I'll tell you the reason why. So guys, if I take the change in momentum in the upward direction, delta P, it has to be the final momentum minus the initial momentum. Sorry? Did I make a mistake? 5.4, sorry, not 6.8, my bad. There's no 6.8 in the business. It's rebouncing with the velocity 5.4. 0.059 into 5.4. 0.3186. That is the rebounding moment. So guys, the change in momentum will be final momentum minus initial momentum. Final momentum is 0.3186. Minus the initial momentum is 0.5133, but the initial momentum is in the downward direction. But we are taking the change in the upward direction, so it's supposed to be 0.3186 minus 0.5133. So that is the reason the two momenta will be added. 0.3186 plus 0.5133. That is 0.8319. To two significant figures, it is 0.83. Is that okay?
So why did they give the ball is in contact with the ground for 0.091 seconds?
Maybe that is needed for the next part, not for this part. Okay.
Okay.
This part, I need to find a change in magnitude momentum, so you don't need to use the time.
Okay.
The next part, determine the magnitude of the average resultant force that acts on the ball during this collision. Of course, now here you have to use that time. Force is equal to rate of change of momentum, which is change in momentum over time taken. So the change in momentum is 0.83 over the time taken is the ball is in contact with the ground for 0.091 seconds. 0.091 seconds. So it is 0.83 divided by 0.091. That's 9.1 newtons. Okay, that's the magnitude of the average resultant force that is acting on the wall during the collision. Using your answer in C2, calculate the magnitude of the average force exerted by the ground on the ball during the collision. Now guys, here see, the moment the ball is in contact with the ground, if I mark the forces acting on the ball, there is a contact force acting on the ball by the ground. Correct? And most obviously, the weight of the ball will be acting downwards. What is the weight of the ball? The weight of the ball is 0.059 is the mass. 0.059 multiplied by 9.81. That using W equals mg. 0.059 into 9.81. 0.579. 0.579, that is the weight. So the resultant force is going to be, now the ball is getting hit by the ground in the upward direction. Correct? So the resultant force is going to be upwards. So resultant force is R minus 0.579. That is equal to 9.1. That is the resultant force. So the contact force or the upward force exerted by the ground on the ball is going to be 9.1 plus 0.579. That is 9.679. Newtons to two significant figures. 9.7 newtons. Any questions, anyone? Please feel free to talk. If you have any questions, ask. Any questions, anyone? Okay. The part D, the ball was thrown downwards at time t, and it hits the ground at t equals capital T. On figure 2.2, sketch a graph to show the variation of the speed of the ball with time t from t equals 0 to t equals capital T. Numerical values are not required. So, air resistance is negligible. So guys, while it is falling down, it will be falling under gravitational acceleration. So it's just a straight line with a constant gradient. That's how the speed will be increased. Just a straight line with a constant gradient. It is falling under constant gravitational acceleration. Is it? Is it heavy? It is projected with a speed, so then in that case, it will be having a small starting speed. So you can show it like this. So there is a constant gradient. Since it is having an initial speed, it will not start from the origin. If it was released from this, it will be starting from the origin. In practice, air resistance is not negligible. State and explain the variation, if any, with time t of the gradient of the graph when air resistance is not negligible. So if there is air resistance, what will happen to the gradient of the graph? It will gradient will increase or decrease. Gradient will increase.
Decrease.
Gradient will decrease. Why? Guys, the gradient of this graph is a representation of the acceleration. So if there is air resistance acting, the weight is acting down, air resistance is acting up. So air resistance will reduce the resultant force. Am I right? Weight is acting down, air resistance is acting up. So as it is falling, the resultant force will decrease. Agree? If the resultant force is decreasing, the acceleration will decrease. Okay. So the gradient of the graph is supposed to be gradually decreasing. So state and explain the variation, if any, with time t of the gradient of the graph when air resistance is not negligible, we can say. Gradient wave. Gradually decrease. So once again, it's a 2 mark. So mentioning it will decrease is 1 mark. A small explanation will get you the other mark. You can write air resistance will increase and the resultant force will decrease. Air resistance will increase when the resultant force will decrease. Okay. Right. Right. Here's question 3. Can you read question 3? Right. Question 3. A child of weight 330 newtons is at a point X. A child of weight 330 newtons is at point X at the top of a slide. The slide is at the edge of a swimming pool, as shown in figure 3.1. The child moves from rest to the lowest point of the slide. That is a vertical distance of 4 meters below point X. The child continues moving towards point Y, which is at the end of the slide and the vertical distance of 1.1 meters above the lowest point. The kinetic energy of the child at point Y is 540 joules. Calculate the difference in gravitational potential energy of the child at point X and Y. At point X and Y, the difference in potential energy. Do you understand this game? Yes. What is happening here? He is sliding down a swimming pool. Okay, or something. He slides down, he comes to this point, and he will jump off like this. Okay. Okay. Have you done this in your life? No. You haven't done this? You have never been to a water park? A theme park? A simple one. Here you have in Sri Lanka, right? You can jump into water. So that is what he is doing. Sliding down this, go down here with a certain kinetic energy, he will jump. Okay. No, he is not sad. Don't worry, Sean. He's a true path. Okay, he will slide down and he will jump. How can you see his emotions? How do you know he's sad? No, he is not sad. He's a happy boy. Now, calculate the difference in the gravitational potential energy of the child at point X and Y. So point X is here. This is the level of X. This is the level Y. So the height difference between the 2 points is how much? 4 minus 1.1. That's 2.9 meters. That's the height difference. Okay. So if you are looking at the potential difference, gravitational potential energy difference between the 2 points X and Y, we use mgh. mg is the weight, which is 330 newtons. Into the h is 2.9 meters. (330 into 2.9), 957 joules. 957 joules. That is to two significant figures, 960 joules. That is the gravitational potential energy difference between the points X and Y. Okay. Part B. An average frictional force of 52 newtons is acting on the child when moving from X to Y. By considering changes of energy, determine the distance moved by the child from X to Y. Now, guys, the child is starting from point X from rest, right? So initially when the child is starting, he or she doesn't have a kinetic energy. Okay. When the child comes to the point Y, the kinetic energy is developed to 540 joules. Okay. But to gain that 540 joules of kinetic energy, the gravitational potential energy that you have spent is 960 joules. Correct? You spend 960 joules of gravitational potential energy to earn 540 joules of kinetic energy. So in the process, you have lost some energy, right? So how much is the energy that you have lost? 960 or 957 minus 550 joules, 540. 957 minus 540. 417 joules is the energy that you have lost. Am I right? That energy is lost because of what? Work done against resistance. So work done against resistance is 417 joules. That is equal to the average frictional force, 520 newtons, into the distance moved from X to Y. Correct? Work done is given by force into distance. So the work done against resistive force will be resistive force into distance. So the resistive force is 52. That multiplied by the distance should be equal to the work done against resistance, which is 417. So D equals 417 divided by 52. 8.0 meters. Is that okay? Any questions? Any questions, anyone? Okay. Right, the next one. The child leaves the slide at point Y with a velocity that is at an angle of 41 degrees to the horizontal. The path of the child through the air is shown in figure 3.2. The point Z is the highest point on the path of the child through the air. Assume that once again there is no air resistance. Calculate the speed of the child at point Y. Guys, at point Y, we know the kinetic energy is 540 joules. So half mv square is 540 joules. So to find what is m, I will use W equals mg. W is 330 newtons. M into G is 9.81. So M equals 330 divided by 9.81. That's 33.64. Or 33.6 kilograms. That is the mass. So half into that mass, which is 33.64 into V square will give you 540. The kinetic energy of the child. From here we can get the V subjective. .67. I'll take it as 5.7 meters per second to two significant figures. Correct me if I'm wrong. And they want you to find the speed of the child at point Z as well. So point Z is the maximum point. Correct? As at the maximum point, what is the vertical velocity? 0. So at point Z, it is only going to have a horizontal velocity. Agree? And also, throughout this whole projectile motion, the horizontal velocity will remain constant. Am I right? So if you take them together, that means the velocity at the point Z is indeed the horizontal velocity at point Y. Agree? From point Y to throughout this projectile motion, the horizontal velocity will be the same. It won't change because there are no horizontal forces acting. So there is no horizontal acceleration. Horizontal acceleration is 0. So horizontal velocity will remain constant. So at point Z, it doesn't have a vertical velocity. So the velocity at point Z is only the horizontal velocity. So with the horizontal velocity at point Z or the horizontal velocity at point Y, it's not different, it's the same thing. So finding the velocity at Z means actually you can find the horizontal velocity at Y. Same thing. Okay. So what is the velocity at Y? 5.7 cos 41. Horizontal component will be cos. So that is going to be 5.7 cos 41. 4.3 meters per second. Guys, you can check the market scheme. This is May 2021, paper 22. Question 4. Can you read the question? For a progressive wave, state what is meant by its period. The time taken for a particle to make a complete oscillation. Time taken for a particle to make a complete oscillation. Or you can also say the time taken for the wave to travel the distance equal to its wavelength. Same thing. The principle of superposition, what is that? When two waves or two or more waves meet at a point, the resultant displacement is the sum of the displacement made by the individual waves. Right? When two or more waves meet at a point, the resultant displacement is the sum of individual displacement. Of waves. Part C. Electromagnetic waves of wavelength 0.04 meters are emitted in phase. In phase from two sources, X and Y, and travel in a vacuum. Wavelengths are 0.04 meters. The arrangement of the sources is shown in figure 4.1. A detector moves along a path that is parallel to the line XY. Pattern of intensity maxima and minima are detected when you are moving the detector along the path given. Distance xz is 1.380 meters and distance yz is 1.240 meters. State the name of the region of the electromagnetic spectrum that contains waves from X and Y. So guys, wavelength is 0.040 meters. 0.040 meters. 0.040 meters belongs to which category of electromagnetic spectrum? Radio? Radio or micro? That you should know. Radio or micro? Check the table and answer. 0.040. Microwaves. What is the range of radio waves? Radio waves is more than that. Check. That's radio. Microwaves is? Yeah, then it should be 0.040 meters means 4 centimeters, right? So 4 centimeters is? What is the range you know for radio? 10 to the power minus 1 means 0.1, that is 10 centimeters and above. Microwaves, what is the range? Then it should be microwaves. Microwave. Okay. Calculate the period in picoseconds of the waves. So where's V equals F lambda? V is 3 into 10 to the power 8. F into the lambda is 0.040. So the F is equal to 3 into 10 to the power 8 divided by 0.04, which is 7.5. Into 10 to the power 9 hertz. Wait. Yeah. So this is the frequency. So the time period will be 1 over frequency, which is 1 over 7.5 into 10 to the power 9. That much of seconds. So if you want to convert seconds to picoseconds, you need to multiply by 10 to the power 12. Is it 1333? 1333.3? Sorry. 133 point. 10 to the power 12 is tera. No, this is I'm converting seconds to picoseconds. To convert seconds to picoseconds, you have to multiply by 10 to the power 12. So 133.3, or to two significant figures, you can give it as 130 picoseconds. Okay. Any questions, anyone? Show them the path difference of point Z between the waves from X and Y is 3.5 lambda, where lambda is the wavelength of the wave. So guys, one path is 1.38 meters, the other path is 1.240 meters. So path difference in terms of meters will be 1.38 minus 1.24. 1.38 minus 1.24 will be 0.14 meters. So to see what is the path difference in terms of lambda, that's 0.14 meters. You divide it by the wavelength, where the wavelength is 0.04 meters. That is exactly 3.5 lambdas. That is the path difference. Okay, agree? Calculate the phase difference between the waves at point Z. So guys, path now at X and Y, the two waves were in phase. Initially they start in phase. Okay. Then by the time they reach point Z, there is a phase difference. That phase difference corresponds to this path difference of 3.5 lambda. So 1 lambda means a phase difference of 360 degrees. Correct? Half a lambda is a phase difference of 180 degrees. So it will be 180 degrees will be the phase difference of the two waves at point C. 3.5 lambda. The waves from X and Y, the waves from X alone have the same amplitude at point Z as the waves from Y alone. So at point Z, the amplitude of the wave that you are getting from X and then the amplitude of the wave that you are getting from Y are the same. Amplitude is the same. The waves from X alone have the same amplitude at point Z as the waves from Y alone. State the intensity of the waves at point Z. What will be the intensity? 0. Now, both have the same amplitude, but they will cancel off each other because they are anti-phase. Phase difference is 180 degrees. So that means the resultant displacement at the point Z is going to be 0. So the resultant amplitude at point Z is going to be 0. Intensity is proportional to the square of the amplitude. So if the amplitude is 0, intensity will be 0. Okay. The frequencies of the waves from X and Y are both decreased to the same lower value. The frequencies of the waves X and Y are both decreased to the same lower value. The waves stay within the same region of electromagnetic spectrum. Describe the effect of this change on the pattern of intensity maxima and minima along the path of the knitting. So guys, now this is similar to the Young's double slit experiment. where there are two waves coming and meeting on the screen. This is equivalent to the screen. Where the path difference is given by, where the distance between two bright spots or the distance between two intensity maxima is given by x equals lambda d over a. Am I right? So now you are reducing the frequencies of the wave speed. Yeah. The frequencies are decreased means wavelength will be increased, right? So the d and a are unchanged. You are increasing the lambda. So that means increasing the x. So which means the distance between intensity maximas and intensity minimas will be increased. Agreed? Describe the effect of this change on the pattern of intensity maxima and minima along the path of the detector. You can say. You can just show this equation x equals lambda d over a and then write lambda is increased. So the distance between intensity maxima will increase. We'll say we put it this way. So the distance between adjacent intensity maxima, adjacent intensity maxima will increase. Okay. Right. Fine. Guys, read the next question. Read the next one. I'll give you a couple of minutes, give it a try. Give me a minute.
Recording in progress.
Yeah, tell me. What is it? A potentiometer is just a wire. Along the wire, the potential difference will vary. Why? What is it? Is there a question we have? Right. Question 5. Define the ohm. Ohm is the unit of resistance. So resistance is volts per ampere. So you can write it volts per ampere. A wire is made of metal of resistivity rho. The length L of the wire is gradually increased. The length L of the wire is gradually increased. Assume that the volume V of the wire remains constant as the length is increased. Show that the resistance R of the extending wire is proportional to L square. So as R is equal to rho L over A. So now for a piece of wire with length L and cross-sectional area A, volume is equal to A into L. So A is equal to volume over L. I can replace this rho L over A. The A I will replace with V over L. So that is R equals rho L divided by V over L will become multiplied by L over V, which is rho L square over V. That is the resistance in terms of length and resistivity and volume. So resistivity rho and V, these are constants. So which means R is proportional to L square. R is proportional to L square. Part C. A battery of EMF E and internal resistance simple R is connected to a variable resistance capital R as shown in the figure. An ammeter measures the current I in the circuit. The voltmeter measures the potential difference V across the variable resistor. The resistance R is now varied to change the I and V. The variation with I and V is given below. V versus I is given below. Using the figure 5.2, state the EMF of the battery. So guys, I have told you, when the current is 0 in the circuit, the voltmeter reading will be straight away equal to the EMF. When there is no current in the circuit, straight away, that is this point. At this point, the voltmeter reading is the EMF. So how much is that? 2.4 volts. So the EMF of the battery will be 2.4. Then using the figure 5.2, determine the power dissipated in the variable resistor when there is a current of 5 amperes. Now power dissipated in the variable resistor when there is a current of 5 amperes. So when the current is 5 amperes, you can find the voltmeter reading here 1.3 volts. So if I use P equals VI, V is 1.3, I is 5. That's 6.5 watts. Agree? Power is 6.5 watts. State what is represented by the value of the gradient of the graph. So guys, we know V equals E minus IR, where IR is a loss voltage, E is the EMF. So if you rearrange it, V equals minus R times I plus E, where V is taken in the y-axis, I in the x-axis. So it's y equals mx plus c. So the gradient of this graph is equal to what? Negative of the internal resistance, isn't it? Yeah. So the gradient state what is represented by the value of the gradient of the graph, you can say it is the negative of the internal resistance. Of internal resistance. Oh, that's it. The next one, the last one. Read the question. Okay, one of the results of the alpha particle scattering experiment is that a very small minority of the alpha particles are scattered through angles greater than 90 degrees. Sure, state what may be inferred about the structure of the atom from this result. So more than 90 degrees, a very small minority of the alpha particles is what? Deviated through an angle greater than 90. So what can we say based on this? The most of the mass of the atom is concentrated in a small volume or small region at the center of the atom. You can see most of the mass of the atom is concentrated at a very small region at the center of the atom. Most of the mass of the atom is concentrated at a very small region at the center of the atom. Alpha particle is made up of other particles. One of these particles is a proton. Alpha particle is made up of whatever? Two protons and two neutrons. State and explain whether a proton is a fundamental particle. Is it? No. Why not? It's made of quarks. No. It is made of quarks. Yes, correct. Same meaning. Right. A radioactive source produces a beam of alpha particles in a vacuum. A radioactive source produces a beam of alpha particles in a vacuum. The average current produced by the beam is 6.9 into 10 to the power minus 9 amperes. Calculate the average number of alpha particles passing a fixed point in the beam in a time of 1 minute. In a time of 1 minute. So guys, Q equals IT. I can find the charge passing in 1 minute. 6.9 into 10 to the power minus 9. Into the time is 1 minute, that is 60 seconds. So the amount of charge passing in 1 minute will be 4.14 into 10 to the power minus 7 coulombs. So this much of charge will be passing through a point in 1 minute. I want to see how many alpha particles are passing. So if you take one alpha particle, it consists of what? 2 protons, 2 neutrons. The 2 neutrons anyway don't have a charge. Correct? So the charge of an alpha particle will be 2 into charge of an proton, which is 1.6 into 10 to the power minus 9. Proton and electron have the same charge. The difference is electron is negative, proton is positive. So charge of a proton is charge of a alpha particle is 3.2 into 10 to the power minus 19 coulombs. This is the charge of an alpha particle. Then to see how many alpha particles are needed to carry this charge, we divide 4.14 into 10 to the power minus 7 divided by the charge of an alpha particle, which is 3.2 into 10 to the power minus 19. That gives you is it 1.3 into 10 to the power 12? So this much of alpha particles will be passing in a minute through the point. And the next part is something to do with the uniform electric field. Whereas that is not there in the syllabus anyway for AS levels. Electric fields are removed from the syllabus in the new syllabus. Right. So that's all for this paper. No, there's another part E. That is also something to do with the electric field, so which means it's not there. Right. So there's another paper I have sent you, which is 2021 paper 21. Yeah. Yeah, we will do one question and then take a break. Okay. The first question is very tempting from answer. No, you like answer, right? Please do it. Question 1. We'll do this question and take a break.
So when they say define something, can you just write the formulas?
But you have defined the terms, whatever you are using in the formula. Yeah, that's okay. Okay, define density. It is the mass per unit volume. Mass per unit volume. The figure shows a solid pyramid with a square base. The mass end of the pyramid is given by 113. Rho hx square, where rho is the density of the material, which is the height, and x is the length of each side of the base. Measurements are taken in the where it's given below in the table. Calculate the absolute uncertainty in length x. Absolute uncertainty in length x. So guys, x is 4 centimeters measured. Uncertainty is 5%. So the absolute uncertainty will be 4 into 5%. What is 4 into 5%? 0.2 centimeters. Okay. The next one. The density rho is calculated from the measurements in table 1.1. Determine the percentage uncertainty in calculated value of rho. M equals 103 rho hx square. M equals 103 rho hx square. So if you get the rho subject, rho equals 3m over hx square. So the PUC of rho, percentage uncertainty of rho, is equal to PUC of m plus PUC of h plus 2 times PUC of x. It's 2 times PUC of x because of x squared. Correct, right? So PUC of m, percentage uncertainty of m is 2%. PUC of h is 4%. PUC of x is 5%. 2 into 5 is 10%. 10 plus 2 plus 4 is 16%. Then the percentage uncertainty of rho. The square base of the pyramid B rests on horizontal surface of a bench. Using the data from table 1.1, calculate the average pressure of the pyramid on the surface of the bench. The uncertainty in your answer is not required. Calculate the average pressure of the pyramid on the surface of the bench. So guys, the pressure is equal to force over area. Force is mg over area is x square. The base area is x square. Okay. So m is 103 rho hx square. No, but we know the m. That's 19.5 grams. 19.5 grams into 10 to the power minus 3 to convert grams to kilograms. G is 9.81. X is 4 centimeters. That is 0.04 meters. And square it. $120 to 2 significant figures. 119.6, 120 to 2 significant figures. A person uses a trolley to move suitcase at an airport. The total mass of the trolley and the suitcase is 72 kilograms. The person pushes the trolley and the suitcase along a horizontal surface with a constant speed of 1.4 meters per second, and then releases the trolley. The release of, please keep your mics mute. The release trolley moves in a straight line and comes to rest. Assume that the constant resistive force at a constant total resistive force of 18 newtons opposes the motion of the trolley and suitcase. Calculate the power required to overcome the total resistive force on the trolley and suitcase when they move with a constant speed of 1.4 meters per second. So where power required is equal to force required into velocity. Calculate the power required to overcome the total resistive force. So what is the resistive force? Resistive force is 18 newtons. So the power required to overcome the resistive force will be 18 into the speed is 1.4. 18 into 1.4 will be 25.2 watts. Calculate the time taken for the trolley to come to rest after it is released. Okay. If I use F equals ma on the trolley, there is a resistive force of 18 newtons acting horizontally. So the resultant force is minus 18, which is against the motion. Mass is 72 kilograms, suitcase and the trolley. Acceleration is 8. So the acceleration is minus 18 over 72. That is minus 0.25 meters per square second. That is the acceleration. So to see what is the time taken, calculate the time taken for the trolley to come to rest, I will use V equals U plus 80. When it comes to rest, V equals 0. The U, the initial velocity is 1.4. A is minus 0.25 into T. So bring it to the left. 0.25 T equals 1.4. T equals 1.4 divided by 0.25. 5.6 seconds. To the next one, part B. At another place in the airport, the trolley and the suitcase are on a slope, as shown in figure 2.1. Okay, now it's on a slope. The person raises the trolley from rest at point X. The trolley moves down the slope in a straight line towards the point Y. The distance along the slope between points X and Y is 9.5 meters. The component of F, the weight, the component F of the weight of the trolley and suitcase that acts along the slope is 54 newtons. Assume that a constant total resistive force of 18 newtons is opposing the motion. Calculate the speed of the trolley at point Y. Calculate the speed of the trolley at point Y. Right, whereas if I use F equals ma down the slope, if I use F equals ma down the slope, F is the resultant force. 54 newtons acting down the slope, 18 newtons opposing that. So the resultant force will be 54 minus 18. Okay. And the mass of the fellow is how much? 72. Into the acceleration. So 54 minus 18 is 36. 36 divided by 72 is equal to A. So A equals 36 over 72 is 0.5 meters per square second. That is the acceleration. Now with this acceleration, it is moving down the slope a distance of 9.5 meters. We have to find the speed of the trolley after me moving 9.5 meters down. So I can use the equation 1. V square equals U square plus 2V. The V is what we have to find, V square. U is 0 because it starts from rest, right? The question says it starts from rest. So 2 into A is 0.5 into the S is the distance, which is 9.5 meters. So the V is equal to square root of that value, which is 3.08, or to two significant figures, it will be 3.1 meters per second. Calculate the work done by F for the movement of the trolley from X to Y. So guys, F is 54 newtons. 54 newtons force into distance will give you the work done. Distance is 9.5. So 54 into 9.5, 513 joules. Not really. The question says calculate the work done by F. Work done by F. So that is force F into the distance. Work done by F. Any question? Okay. Any questions? No. Sure. Hello, people online.
So the frictional forces is not counted because it's F.
Because they are asking here the work done by the force F, right? They need
Not
to
the-
find force. Okay.
Okay. Okay.
Part 3. The trolley is released at point X at time t equals 0. On figure 2.2, sketch a graph to show the variation with time t of the work done by F. For the movement of the trolley from X to Y, numerical values of the work done and the t are not required. How will be the graph? Work done versus time. So work done is equal to force into distance, right? Force is constant. The distance is, guys, if I use down the slope, SC equals, down the slope, if I use SC equals UT plus half AT square, listen to me. SC equals, UT part is 0, half acceleration into T square. So SC equals half AT square. So it is work done equals force into half AT square. So basically, W is proportional to T square. F is a constant, force is a constant, acceleration is a constant. So work done is proportional to T square. How will be a W proportional, Y is proportional to X square, or work done is proportional to T square? How will be a T square graph be? Is it this? What is this one? What is this graph? W is proportional to T. W is directly proportional to T. What is this graph? No. That is this. This is W is proportional to 1 over T, or W is inversely proportional to T. That is this graph. Inverse proportion. What is this? W is proportional to the square root of T. Okay. So what is W is proportional to T square? That is this. Okay. This is what we have sketched in O levels. The graph of y equals x square. Graph of y equals x square looks like this, right? O levels. You draw the graph of y equals x square. So that is y proportional to x square. So if you consider only for the positive values of x, this is how the graph is going to look like. So W work done is proportional to t square. This is how the graph will be. If you have any questions, please stop. Okay, right. There's part C. The angle of the slope in V is constant. The angle is constant. The frictional forces acting on the wheels of the moving trolley are also constant. The angle is constant. The frictional forces acting on the wheels of the trolley are also constant. Explain why, in practice, it is incorrect to assume that the total resistive force opposing the motion of the trolley and suitcase is constant as the trolley moves between x and y. So when it is moving from x to y, if you take the total resistive force, will it be constant or not? My dear darling students, listen to me. If I say the total resistive force, there are two components. One is the friction, which is the friction between the two surfaces. If you take the trolley and the surface slope, there is a friction. Correct? The other resistive force is what? Air resistance. No? While it is going down, there will be air resistance, practically. So will that, now this frictional force will be a constant, correct? Will the air resistance be constant? No, it depends on what? The speed. Faster you move, higher will be the air resistance. Simple. You can always remember this simple example. When you are traveling in a vehicle, if you travel slow, if you go at a lower speed, there will be small air resistance. If you drive fast, obviously you experience a lot of air resistance, right? You can feel that in a motorbike much better. Or even if you are going in a car, if you keep the shutters open, you can probably feel it. Faster you drive, higher will be the air resistance. So same thing applies on any object. Faster the object is moving, higher will be the air resistance. So now if you take this fellow, what is this? Trolley, no? This trolley, when it is going down the slope, the speed is increasing. So the speed is increasing means the air resistance will be increasing. Correct? So the air resistance is increasing means the total resistive force will be increased. It's not a constant anymore. So that is what the question says. Explain why in practice it is incorrect to assume that the total resistive force opposing the motion of the trolley and suitcase is a constant as the trolley moves between x and y. So you can say as the speed increases, air resistance will increase. All right. Question 3. A pendulum consists of a solid sphere suspended by a string from a fixed point P. The sphere swings from side to side. At one instant, the sphere is at the lowest position x, where it has a kinetic energy of 0.86 joules and a momentum of 0.72 Newton seconds in a horizontal direction. A short time later, the sphere is at point y, where it is momentarily stationary, that means it is having a zero velocity for a moment. For a moment, it is stationary. At a maximum vertical height, it's about the point position x. The string has a fixed length and a negligible weight. Air resistance is also negligible. On figure 3.1, draw a solid line to represent the displacement of the center of the sphere at position y from position x. Okay. Guys, displacement means the shortest distance between the initial and the final points. So the displacement of y from x means you connect these two centers with a straight line, that is the displacement of the point y with respect to the point x. Show that the mass of the sphere is 0.3 kilograms. Show that the mass is 0.3 kilograms. As you see, kinetic energy is half mv square. That's equal to 0.86 joules. Momentum is m into v. That is 0.72. Am I right? Agree? Look at this. If I get the v subjected from here, that is 0.72 over m. Bring it and substitute it here. Half m v square. V square will be 0.72 over m, that square. That is equal to 0.86. That is half m. 0.72 square will be 0.5184 divided by m square, that is equal to 0.86. So these m square and m will cancel off. One of these m's will cancel off with the same. So 0.5184 cross multiply 0.86 multiplied with 2m. This 2 and m multiplied with 2m, that cross multiplied to 0.86 into 2m. So m is equal to 0.5184 divided by 2 into 0.86. That is 0.301 or 0.30 kilograms. That is the mass of the object. Okay. Part C, calculate the height h. Part C, calculate the height h. Guys, there is no air resistance. So that means from here to here, x to y, the gain in gravitational potential energy should be equal to the loss in kinetic energy. There's no other mechanical work being done. There's no other resistive force. There is no other engine or anything. So x to y, gain in gravitational potential energy, mgh, is equal to loss in kinetic energy. Loss in kinetic energy is how much? 0.86. Because it has a kinetic energy of 0.86 at the bottom. So when it comes to the maximum height, the kinetic energy will not be there. So the loss in kinetic energy is 0.86. That is equal to the gain in gravitational potential energy, mgh. So the m is, we just found it to be 0.3. G is 9.81. That into h equals 0.86. So the h equals 0.29 meters. The distance between the point P and the center of the sphere is 0.93 meters. Point P and the center of the sphere. This one. This is given 0.93 meters. When the sphere is at position Y, the string is at an angle theta to the vertical. Show that theta is 47. This angle is what they want you to prove. So guys, simple, grade 9 maths, simple trigonometry. Okay. So we found the h to be 0.29 meters. H is 0.29 meters. Look at this. I will take this triangle. If we take this triangle, this length is 0.93 minus 0.29, 0.64 meters. Am I right? This is h is 0.29. This whole thing is 0.93. From the 0.93, if you remove the 0.29, you are getting 0.64 meters. So this one is 0.93 meters. So if you take this angle theta, this is the adjacent, this is the hypotenuse. Adjacent and the hypotenuse are connected by sine, no? Cos. Cos theta equals adjacent over hypotenuse. Cos theta 0.64 over 0.93. Get the cos inverse, you are getting the answer. So theta equals cos inverse 46.5. That is 47 degrees. That's the theta. For the sphere at position Y, calculate the moment of its weight about the point P. When it is at point Y, we have to take the moment about point P. So guys, the moment is given by force into distance. So weight at Y is acting at this point. And if I extend this line, the perpendicular distance from P to the weight is this much. So how much is the weight? Moment is equal to mg into d. The m is 0.30. G is 9.81. Into d is this distance. To measure that distance, that is this distance, I will take sine theta. Sine theta equals, this is opposite, d over hypotenuse is 0.93. This length is 0.93. So theta is, we already found it to be 47. So d equals 0.93 into sine 47. That's 0.68. So the moment is going to be mg into d. Mg is 0.3 to 9.81, D is 0.68. I'm getting 2.0 Newton meters. Correct me if I'm wrong. Okay. State and explain. You check. Correct, right? State and explain whether the sphere is in equilibrium when it is stationary at position Y. So at position Y, it's momentarily at rest. That means it's at rest for a moment. But is it under equilibrium? No. There is easily because there is a moment acting, right? So if there is a moment acting, it can't be under equilibrium. So state and explain whether the sphere is in equilibrium when it is stationary at position Y. No. There is a moment acting. On the sphere. Okay. Right, guys, there are 3 more questions. I want to do one before we stop. There is one from waves, one from electricity. Which one you want? Waves or electricity? Wave. Okay. Let's do question 4. For a progressive wave, state what is meant by the wavelength, the distance between two adjacent waveforms. Okay, you can define either the distance between two adjacent wavefronts or the distance between two adjacent particles that are vibrating in phase. The distance between two adjacent particles that are vibrating in phase. A light wave from a laser has a wavelength of 460 nanometers in a vacuum. Calculate the period of the wave. So guys, the frequency is equal to V over lambda. V is 3 to the power 8. Lambda is 460 nanometers to meters 10 to the power minus 9. That is the frequency in hertz. That is giving you 6.52 10 to the power 14 hertz. So the time period will be the reciprocal of it. That is 1.53. Into 10 to the power minus 15 seconds. (1.53) into 10 to the power minus 15 seconds. The light from the laser is incident normally in a diffraction grating. Describe the diffraction of the light waves at the grating. The light from the laser is incident normally in a diffraction grating. Describe the diffraction of the light waves at the grating. What is diffraction? The spreading of out of the wave when passing through. The spreading of the wave when passing through the slits. Okay, it's a 2 marker. Can you please check the marking scheme? What is the marks given for? They have the mark. Have you opened the marking scheme? Any mark? Check, please. Anyway, part D. A diffraction grating is used with the different wavelengths of visible light, the angle theta of the 4th order maximum from the 0 order central maximum is measured for each wave. So they have given the sine theta versus lambda graph for the 4th order maximum. Okay, fine. The gradient of the graph is G. Determine an expression in terms of G for the distance D between the centers of the 2 adjacent slits in the diffraction gradient. So guys, D sine theta equal in lambda. This is what we use for a diffraction gradient. D is the distance between 2 adjacent slits, that's fine. So D sine theta equals N is 4 because it's a 4th order maximum. So if I get the sine theta subjected now, sine theta equals 4 over D times lambda. Sine theta equals 4 over D times lambda. So which means the gradient G is equal to 4 over D. Oh wait, gradient is equal to 4 over D, but they want an expression for the D in terms of the gradient. So D equals 4 over G. Okay, correct. On figure 4.1, sketch a graph to show the results that would be obtained for the 2nd order maximum. So guys, 2nd order maximum means the same thing, but the difference is now it will be D sine theta equals, instead of 4 lambda, it will be 2 lambda. So which means if you get the sine theta subjected now, sine theta equals 2 over D times lambda. Correct? So earlier the gradient was 4 over D. Now the gradient is 2 over D. So which means the gradient is becoming half. Okay, simple maths. The gradient was 4 over D. Now the gradient is 2 over D, which means the gradient is becoming half. So draw a line with half the gradient. So which means for every lambda value, the sine theta value will become half. So for 400 nanometers earlier, there is a certain value for the sine theta. So now it will become half of that. So for 700, it is here. So half of that will be here. Okay. So connect them. For each lambda value, half the sine theta value. That will give you the graph with half the gradient. If you have any questions, please stop. Okay. Right, guys, there are 2 more questions remaining. Please complete it on your own. And if you have any question, we can bring it on the next week. So next week, once again, we will be doing, if it is a MCQ paper, we will be discussing 1. If it is a paper 2, we will be discussing 2 papers. That's it for the day. Have a nice weekend, people. See you. Take care. Bye.